So dear participants, thank you once again for joining the session. Once again, kindly wait for 2 minutes. Let it join other participants. Then we'll start the session within 2 minutes, please. So let's start the session once again. Okay, so I would like to share my screen. So I would like to start from scratch again the session. So thank you once again to all the participants. So I would like to open the software again from my directory that is called C Drive Device Studio. Inside that there is a Device Studio application files. So I want to open it and want to create from scratch. So create new project and OK. And then define the name of the project as an example rescue. And maximize. So yesterday, basically, we learned about how to calculate the band structure and density of states. Where we have a lot of things are there in the software. There are so many parameters you can calculate. We will discuss in these all 5 days. We have a lot of content for you. So in today's session, we will try to calculate some optical property, Raman property, and phonon calculations. So let's start the session. I want to start from the file section and then click on create new crystal. So as an example, I want to create a diamond crystal. So I open this crystal builder where I want to create one diamond crystal from the scratch. So I make one crystal. I want to select the space group. Let's suppose this is the space group. I have taken simple cubic Brevis lattice and want to create a new project. I want to define the cell length, E value for the simple cubic structure, and would like to define the coordinate points. I click on this plus sign, click on add. By default, carbon is added. I want to add multiple options. So next, I want to add another carbon element. This is the default element, but we can also change it. Then again, I want to click on this plus. And I want to take these positions. The next position of the carbon element, I'm trying to calculate the diamond crystal. So I click here and then I can see the preview. Now you can see here the diamond crystal is created. I simply defined all this carbon element with their fractional coordinate points. So this is the point which I have defined here. And accordingly, the diamond crystal is created. The atomic positions are fixed, whatever I have mentioned here. If you want to change any element, you can select here and you can choose the particular element according to your needs. So any material, if you do not have any material files or data is not present, material is not present in our library, then by following the same procedure, you can create any kind of structures. As an example, I have created this diamond structure. So this primitive cell, I can see it and click on build button. Now this structure, which I have created in front of you in our software, instead of dependency to create in any other tools. Now to calculate, we will calculate first of all some phonon property, Raman property, optical property, then many more things will be done. So to calculate using rescue, I will go to the simulator and then go to the rescue and go to the DFT calculation, density pattern perturbation theory. Either I can do the calculation for phonon band structure, phonon density of state, or phonon band structure and density of states. I have selected both of them. You can define these parameters by reading your different literatures, real space method, and different LDA or GA functions, action correlation functions. It will calculate the charge density, total energy, mixed steps, and DFT method, perturbation, and CFSI solvers. The theoretical part you have to inquire from the research papers and then go to the basis sets. Defaultly, carbon element double zeta polarized basis sets is selected. But if you want to take single zeta polarized or some other element, user defined basis sets can also be taken it from the library or wherever you want to upload. Then go to the spin type. I can scroll by putting the
Sir, are you talking? There is no sound. Are you talking?
run since version will be only for single core, but whenever you will purchase it, you will be able to run on parallel calculations. If participants will have any query, you can put it your questions on our group, WhatsApp group. So simulation for this SCF input file, you can see in the background, it is running. It is a calculation log bar. I want to put it this dielectric.input file in the run also. And similarly, other input file, I want to run it. These all input file are automatically generated from the user interface. So I want to put it into queue. And in the bottom of the page, the job manager, it is showing the calculation is running. It is showing the calculation here. So this is the calculation which is running here. Simulation is running here. And I can see here the calculation which is running. Main SCF input file has finished the calculation. Next dielectric is running the job, then phonon Bandstructure, and density of states. One by one it will be execute, then we can plot the output. If you want to check the background script code generated, in the meantime, you can right click and click on open with. It will automatically generate a script from the user interface itself. So automatically once the calculation finished, the top pop-up window will come up. Similarly for dielectric one, you can right click and click on open with. It will give the information about the background code from the user interface. Once phonon will done, then we will start the Raman and optical property, and then more features are there that we will try to explore to you. Now the simulation is running already. In the meantime, if you want to perform some other modeling, then we can open some different file. So I can, simulation is ongoing. In meantime, I want to import some different other materials. So that parallelly I can run the calculation for other structure as well. So I click on the file option and then click on import option, where I can click on import online. And let's suppose I want to take another element that is called aluminum nitride. So I click here and click on search bar. One minute. So I click on this file option, click on import and import local. And here I can search my material. So I search aluminum nitride and it will give all the information related to aluminum nitride. And then let's suppose as an example, I want to take this Al2N2 and click on add button. So the material has been added here, that you can see the material is added. Now I want to perform this calculation for optical analysis. I go to this rescue DFT and then perform the optical calculations. And these are all optical property calculation features. We can define these iteration control, basis sets. For aluminum and nitride, both double zeta polarized is selected. Then go to the spin type, which is not there, and damping factor and electrical field directions. I click on the generate file. And here you can see for aluminum nitride, my input file has generated. I will right click and click on run button. So I will run my all input file here by right click and click on run. Right click and click on run. And similarly for optical input file and click on run. In previous one, there was no optical input file because I have selected phonon band structure and density of state. And this time I have selected optical. So that's why the optical input file has generated. If you want to see the input, see the code which is generated from that user interface, DFPT1. Now simulation is completing one by one, and then we will see our analysis output. So it is going and completing. Similarly, you can also perform in your system later this training. So it is keep running, but it may take some time. If some warning will be there, that will also display. So you can see the phonon band structure calculation input has completed. To check the output analysis, go to the simulator. So this one has completed, both of them, phonon band structure and density of state. To check the analysis, go to the simulator and go to the analysis plot. And we have to go to the same folder. Then I want to go to this crystal, rescue DFPT and result folder. This is my band structure, phonon band structure output. And similarly, the density of state output will also be there. So first of all, let me plot this band structure, phonon 1. This is for phonon 1. This is the density for this diamond crystal with ISO value is there. Those who are facing some installation issue, we can also help you after this training, because during the training, it will be difficult for us. But you can see here, this is for density analysis, which you can do for 3D plot, 2-dimensional plot, and 1-dimensional plot. So along X, Y, X, Z, any Z plane, you can visualize your output. This is other analysis, wave function, potential, neutral atomic potential. You can also calculate it. You want to see the wave function, it will give like that. And similarly for 2D analysis and 1D analysis. And for AL2 and 2, the simulation is going on. In the meantime, we can try to build some other molecular structure as well. So I can go to the build option and then click on molecule 2D. Now here, if you want to build the molecular structure, let's suppose you want to build a benzene. So I can draw this cyclohexyl. I can mention here cyclohexyl. Then take this, draw single bond. And change this CH3 with carbon, hydrogen. So I click on it and change it with hydrogen, with hydrogen, with the hydrogen, with the hydrogen. Sorry. So I have made this benzene, and then I can apply. So similarly, if you want to build any kind of molecular structure, this is basically a molecular builder where you can build any complex molecule. I try to make simple benzene and click on apply data. Now this benzene is created here, which you can see. I have created that now and would like to apply some force field. So now it's ready. Now earlier I took the crystal structure where some lattice were there. Now I want to take this molecule. I can define rename of this molecule as well. Let's suppose you want to take benzene, the name of project. I took the benzene. And to perform the DFPT calculations, I go to the rescue and DFPT Raman calculation. I go to this Raman spec property calculation and take default parameters. These are all default: incoming photon polarization, outcome photon polarization, incoming photon wavelength, and temperature. I click on generate input files. And I would like to, before I run this file, let me see my existing calculation. Now you can see the existing calculation for this AL2 N2 has been done for optical properties. This is for AL2 N2. All the calculation finished. I can see the folder which contains all the projects. I click on open containing folder and go to this all this input file result window. These are my all outputs. Some of them are generated for MATLAB files. Now this is result folder. In this optical dot input file, I want to write one command to plot my data in MATLAB. Rescue -p space dot results. One minute. because the software has generated the output in the form of .mat file. So I want to load here this file and want to rerun. And click on save button. And then I can click on right click and click on this optical.input file and rerun it. Some of the output will be generated in MATLAB. So I want to load the MATLAB parallelly. I want to open MATLAB and want to show you optical property. So MATLAB is required to plot some data, but those who already have, that's well and good. If you don't have MATLAB basic visualizer, then we can also help you out for the MATLAB installation. Now I want to load the project here, that particular folder. And want that particular project. And go to this folder. And now if I click on this folder, L2N2 optics plot die function. Now you can see I have calculated the dielectric permittivity, real part and imaginary part. So we can share you the MATLAB key later this training today. In today evening we can share you. So this is the dielectric permittivity which can easily calculate it. It is a real part and one of them is imaginary parts. With respect to energy. Similarly, if you want to see this IR intensity, I click on the second plot. This is for IR intensity graph. If you want to plot some optical analysis, energy loss. This is energy loss calculations. And if you want to see the refractive index, this is the refractive index N and K, real and imaginary data. So like that, you can calculate the optical properties. So as you have seen, I have done the calculation in my this device studio and plotted the data in MATLAB. But we also have in future version, we will provide one post-processing software that company is developing so that we will completely try to remove dependency in future. Now this is that benzene molecular, that benzene Raman property calculation input file. We have to run these input also for Raman property calculations. So I want to run in the meantime all these input file. It is running. So simulation is running here. So definitely we will try to cover even the one atom between different crystal lattice interactions. We will try to cover up on that. How you can copy one material or molecule to another crystal. That is also possible. So we will do that in coming session. Now this benzene simulation is going on, which you can see here in the bottom of this taskbar. The calculation is going on and some of them are in queue. If you want to take another crystal, I can go to import online. Let's suppose you want to take a boron nitride. So I select here boron nitride. For Raman property calculation, crystal as well as molecule, both property we want to calculate. So this is one boron nitride single chain crystal. I want to not only a benzene layer crystal, I want to do the simulation. We can calculate this one. Then further things we also provided the license. We provide you the examples also. Even the 2 months license are provided to the participants. So not to be worried, we will provide you everything and we will support you. Just initially let it concentrate and you can put it all your questions. That is not problem. Now parallelly, one benzene simulation is running. I want to run this BN boron nitride crystal as well. Crystal lattice and molecular. Both structure, I want to run the job for Raman calculations. So I selected this Raman property. Let it take the default parameter. But you can do the research and accordingly you can take and click on generate files. Now all the input file are generated. I want to run it. Click on right click and click on run my SCF input, dielectric input, Phonon input, and Raman input. So the simulation in under queue that you can see one by one it is executed. So this will calculate the Raman property, optical property that you already seen here, which I plotted. So you can remember these are very advanced features, I think, which may not be available in other software. For dielectric permittivity calculation. And IR intensity. This is for IR intensity. The results accuracy you have to, based on the input, you can see your output predictions. So energy loss, it's calculated that particular energy value. And similarly, this is for refractive index, for real and imaginary part. So this optical property is possible, phonon is possible, electron is possible, and Raman is also possible, which is simulating. Even in MATLAB, you can also plot some data. But as you know, the DFT takes some time in the calculations. So that's why it is taking it. So once it is finishing, the window will pop up. The calculation status, job calculation status is showing on top of the screen, and next task is executing. So you can kill the calculation or real-time simulation. You can visualize it like that. I want to hide it. These are a lot of other features, other functions where participants can do different kind of manipulation by using the builder, this builder options, as well as the toolbar options. Both will help you to manipulate or to create one structure into the another structure, even the device calculations, transistors calculations, all will be there. We will cover up the session on every topics. And later, if any topic is remaining, then participants can also do in their computers according to your particular needs.
Sir,
Yes, please.
sir, while these DFT calculations, so there are some functionals. So how do we know which functions are used in this?
Your voice is not audible. Can you please speak loudly?
Hello, sir. Am I audible?
Yeah, yeah.
Sir, I'm asking that in these DFT calculations, there are some functionals are used. So depending upon the functionals, there will be the calculations. So how do we know that which functionals are used?
So basically, that research you have to do it, but how it can be done in the software, that I can teach you. But which functions are more accurate for which material, that research you have to do it. In the software part level, I can try to show you how it can be implemented in the software.
Okay, sir.
But theoretical
So, sir,
research, I am not aware. Yeah, please.
Is there any such kind of library or something for rescue that how the codes are written? How can we select the functions? Like we are doing the band structure calculations. So can we have the choice that we can select functionals?
Yeah, definitely. If you go there, you can go to this like rescue SCF calculations and action correlation function. You can see LDA PW, GGA PBE, LDA PZ, LDA BWN, PBE sol. So you have these
Okay, sir.
options,
Okay, sir.
hybrid GGA and meta GGA. So whatever action correlation functions you want to use at material specific application, you can use from here.
Okay, sir.
Yeah. So the movement of device is also possible. Carbon nanotube can be created. One another atom can also be created. It is possible, and we will also do it one by one. All the topics, even in your questions, also we will try to show you how you can move any atom or any crystal you want to add. So you can see this is top. Add option is there. Hydrogen passivation option is there. If you want to move anything, you can click on that, and there is option called move. This is for move positions. So you can move in plus y, plus x, plus z, minus z. So along x, y, z, along vector, along screen view, whatever element you want to move, movement is also possible. So we will show you how you can move different things. So this option on the top, there is option called move. So once you will select any element, you can move the atoms. So you can move it, you can mirror it. Mirror is possible. So basically, we will go as for our agenda. We have device options also. We will cover up the device features also. So one by one, we are going into the sequence because we are keeping with the sequence. We will also cover the device application, transistors application, different device. We will try to build and show you. So not to worry about that, but be patient. If you want to do it by yourself, we already have some YouTube channel and we created some different lot of structures. The simulation is running. The device calculation will be performed by using the NanoDcal software. This software is there, which works on device simulation as well as this transistors applications. So not to be worried, we will provide some manual tutorial example videos. Once you completed this workshop, attended fully, you will got a lot of things. And even the license is there. After this 5 days also, if you want a specific problem, then we will also try to help you. But simulation will take some time, as you know, it is running live calculations. And even we have some already simulated project. So if I can open my existing project, we also have some sort of simulated project. So I can go to this 1 minute. On my desktop, I have some rescue tutorials. I can extract this. I have many tutorials in my this GIF folder, which I can share with all the participants after this demo session. Nanowire is possible, MOSFET is possible. We have these tutorial for rescue. Even for device simulation, we have a lot of tutorials. Where we have calculated optical, some Raman. So if I will see this existing one, these properties we created earlier. So simulation may take time, but in your computer, if you want to perform, you can also do the calculations. But I can show you live in this particular. I would like to open another window of this device studio so that one simulation will be running parallelly, and I can show you output in the second window from my existing simulated project. So let me run from existing project. So let me load my existing project and would like to show you some output. So this is basically a Phonon band structure for graphene, which is calculated with different billion joules root point. And let's see some other analysis. See how the calculation is performing. Actually, it is taking some time, so you have to wait it. I do not have Raman calculations projects, so let it wait for 2 minutes. But I am trying 1 minute.
This is Phonon band structure. Actually, for Raman, the calculation is ongoing. Once the finished the calculation, then we can also plot the Raman intensity and other characteristics. Okay. So in the meantime, you have to wait it only. And this is for density of states. So simulation is ongoing, but I want to show you. Let us create some other structures. Okay, in a second device studio project. So what I will do, I want to create. Let's suppose as an example, we want to build the structures. So I want to create the import local, and then go to the semiconductor, or even we can take this silver. So one silver is there, and one material I have that is called silicon. This is silicon, and this is called silver. If you want to make the heterostructures, that you can go to the build option and go to the interface builders. So I want to create one silicon, select, and one silver. Any tool element you want to make heterostructure, click on match, and this is number of atoms. Click on preview. Now you can see the heterostructure can be created like that. So silver and this silicon, we have taken two elements and created the heterostructures. So whatever the number of element, total element, angle, rotation, area, mismatch percentage, strain U, strain B, strain theta, this will display here. You can build it. This is one example where we have tried. Anything is mismatching, it will also show the mismatching percentage. So let me try to repeat the structure. Let's suppose this is silver. I have taken silver and silicon interface. Now I want to take silver and gold as an example. So I import the two material. One I have imported silver. You can see this is silver Ag, which you can see this one. This is lattice of silver. And if I take on this gold, this is gold, same lattice type. Lattice type is same. Once you have loaded both the materials, silver and gold, or any two material as a reference, I have taken these material. Whatever research you are going on, you can also do the same process. Then go to the build option and go to this interface builder. And here you have to select the material. In between, you want to make the interface. So I have selected silver, and second material I have selected the gold. All the so many materials are here, but out of them, I have selected Ag and Au and want to make the interface. So grid size, number of times repetition,
rotation, increment, strain on first surface, second surface, both the surface. Click on match. Once I click on match, this is number of atom and mean absolute strain in percentage. Accordingly, total number of atom, angle, rotation, mismatch percentage, area, strain, and click on preview. Now you can see the gold and silver interface is created. And click on this build button in the left column. Now you can see this is the interface. If you want to zoom it, this is the zoom button. Click on this zoom button and then you can zoom the regions. So I have taken as an example this material, gold, silver, but whatever other element you want to take, it's up to you. The lattice should be similar, like it should be a simple, both the materials should be simple cubic or FCC type or BCC type or rhombohedral type. If any lattice mismatch is there, it will also show there is some problem in the lattice mismatch. If the atom are not properly bonding, now in this particular structure it is bonding, but if it is not bonding, right side you can see there is an option called recalculate linker bond. This option basically will calculate the bonding between two different elements. Recalculate again bonding, if it is there, the atoms are neighboring, it will show the bonding. If atom is not near to each other, it will disbalance the bonding. So this last option, if anything is not bonding properly, then click on it. It will make arrangement accordingly. So the algorithm it automatically implement. As you know, the Raman property Phonon calculation takes some time. So that's why you require some parallel license for parallel calculations. So this is a builder option. First of all, you have to load the material in this input file and output file project window. This is one input file, output file project window, which you can load the material from import online, or import local or new. The main thing is that the material should be present in your user interface. Once the material is loaded in this particular area, like I have loaded this silver and gold. Let me delete this existing interface which I created right now. I can right click and delete the files. I would like to remove this file from project. Similarly, this project file, I want to remove it. And these material I have loaded from my library. If you want to delete, you can also delete it. And to load it, click on File, Import Local, 3D Material, Conductor, Pure Metal, and I can load the silver. Gold AU is also present, which I already loaded in this left screen. Click on OK. Now it is loaded. Both material are there. Just you have to go to the build option, click on interface builder and choose that element. The silver you can choose one time, which I already previously selected. That's why it is showing that it is selected already. And similarly, you have to choose from this drop down menu. These are all material which is present in your user interface, loaded already. That's why all material are showing here. Then click on this match button. Here this is number of atom, mean absolute is 10%. Accordingly, total number of atom, angle, rotation, mismatch percentage will display. Strain on first surface, second surface, or both the surface, whatever you want to select. click on Match, select on particular point, and click on Preview. You can see this is the interface that is created now. And bottom of that, there is an option called Build button. Once you click, your structure is ready for the interface one. So many materials are present in the library. If not present, I already suggested that how a new people can create the materials. New material can also be created, as I created in the at 3 p.m. starting session, how the diamond crystal was created. So user can create it easily. Optical property I already shown you. If not attended, you can watch the recorded video of this lecture and you can see how optical property can be calculated. Now, by following this procedure, you can make the heterostructures, interface structures. Okay. And then you can run the calculation by using rescue also or NanoDcals also. If you see in the builder option, there are a lot of things are there to build it. So molecular builder, molecule 2D, decomposition, device, convert your material into the device can be converted, interface, multiple layers can also be create the interface. Let's suppose you want to make the interface with 3 material, 4 material, 5 material. So you have to adjust your screen. If it is not showing your screen, in your laptop screen maybe smaller, you have to minimize or maximize or adjust in your screen. So you can see here, these are all options. You can create the surface also. If you want to make the surface structure, let's suppose this is silicon crystal. You want to make the surface. You can click on this surface one. In the surface structure, you can cleave the plane. You have to cleave the plane by defining the Miller indices, HKL value, 100 plane, 111 plane, 00 plane, or whatever the plane. According to that, the outer layer, the surface planes are created from the single crystal. This is for planar structure, surface structures. If you want to add any vacuum, this is vacuum can be added, slabs can be added. You can add the slab also. And you have to define the slab thickness, vacuums also. So surface slab is possible and you can define the Miller indices and you can also get it simulated. So then you can click on build button. Your surface will be ready here. You can see silicon 100 surface structures. If you want to change the plane, this is XY plane, which you can visualize here. You can see the XY plane, XZ plane, YZ plane, YX plane, or ZX plane, so that you can make proper alignment. You can also define some stretch your cell as well. You can see this is a stretch cell. If you want to define some strain stress, you can see you can set a stretch factor for each unit cell vector, and then you can apply to activate the changes. So this is for to stretch your crystal lattice cell and define some strain tensors as well. So this toolbar, there are a lot of other options are there. Once you will explore, then you will become familiar with each capability of the software tool. If you want to make three material as an interface, then what you can do, you can go to the CAD2 atomic. In the CAD2 atomic, you can create the rectangle 1, rectangle 2. You can click again and create another rectangle and align it. Then create again and align it. And let's suppose these are three materials. I have to set the material. Let's suppose this first material is called silicon. So I have assigned silicon. In the middle rectangle, I want to set material as a example gold. No, sorry. Let's suppose you want to take middle one as a silicon, and this left one as a silver. I have choose it, and this right one as a gold. So this is three material. This one is called silver, this one is called silicon, and this one is called gold. These are three different material. We can draw the rectangle like that, and then click on calculations. And then we can click on preview. Now this three materials interface is ready. Left side left side silver, middle center silicon, right side gold. So this interface three material is created. And then click on build. Now I have shown you how to create a two material interface or three material interface. This structure was for two material, silver and gold, and bottom one that is called for three material interface. And then if you want to do the simulation for this kind of structure, even multiple combinations are possible. The interface will help you to model your structure very quickly. You can see the simulation is going on for different other that previous benzene job status. So you know the simulation takes time, DFT takes time. That's why. But once the simulation finished, then definitely you can visualize your results. So for one thing is that this is for interface builder where you can make an interface of two material. And these other options will help you to create other, even nanowire is also there. Nanowire will be enabled for the surface structures. One, not this one, not for silicon. For gold surface, it will be enabled. You can see that a nanowire is also enabled now, and grain boundary. All functions are enabled. So the light source is also possible, where you can define some incoming photons. So that basically come in the NanoDcal part, where you can also follow the light incoming photon, and you can calculate the photocurrent. So I have shown you simple band structure, density of state, Raman, optical, but so many things are there, even at the material level also. That will show up in coming session. Density of state, this is for NanoDcal analysis. Density of state, effective potential, total energy, band structure, charge, Hessian, phonon band structure, electron density, potential, transmission channel, Eigen State, full band structure, effective mass, complex band structure, ZT, phonon, modulus. These all analysis can be done. These are at material level, but for device calculation, IB, photon, transport coefficient, transmission spectrum, that will also be there. There are a lot of features that is not disclosed till now, but we will discuss in all the sessions. Let me take one example of the device, which is already there in example, but we can show you how we can build it. When somebody is asking, so I go to this example. This is one example of device features. This is anode, cathode, and molecular junctions. This is for device application. We will show you in the training session how live you can create the device structures. Okay. So that's why for the device analysis, if you are in hurry, I can show you the analysis part. These are device output. Device density of state, effective potential, total energy, scattering state, transmission coefficient, photocurrent, in IV curve, charge, electron density, potential, conductance, thermoelectric current, seebeck coefficients. These all analysis are possible. Even incoming light fall, photon energy range, minimum, maximum. So we will discuss in this whole 5-day session each feature of the software. So be patient, be explore, and license is given to you so that you can also do at your ends. And simulation is running, it may take some time. So, but I will share you the project of this particular structure. Once the calculation is done, then the whole project I will upload and share with you so that you can also load in your system, in your license given user interface, and you can also try to build it. But if you want to see it, how the Raman calculation is performed, then I would like to suggest you can visit the channel. This particular video, you can see Raman spectrum calculations of boron nitride crystal and benzene crystal, where these properties are calculated. So related to rescue, you can refer to this video playlist. And for NanoDcal, I want to share you this list of, you can visit. And similarly, you can perform all the calculations we have tried to explain in these videos. Already 1.5 hours tutorials are there, even different other applications. If you want to go for NanoDcals, you can go to this bottom of the playlist where how different applications are performed. We have done in these videos. Even we will also try to show you live as well. Okay. And if you have a format in ATK file, you can also see there is an option called convert option. So this is distance measurement, right side you can see. This is distance measurement tool. So you can define the length and then you can measure length, width, height, all these things can be measured from this distance measurement tool. So if you want to measure anything, you can click on one atom and then click on another atom. It will measure the distance. Like I have measured this length. You can see this is 35.956 angstrom is the length from one atom to another atom. Similarly, if you want to measure vertically, you can measure the vertical length of the crystal. I can select it, click on one atom and then another atom. It will measure it. It has calculated around 4.080 from this particular atom to this particular atoms. So the complex structure, those who want to create a complex structure, it is possible. Only just you have to invest your time. That's why the license is given, where you can also try to invest your time and you can create your desired shape. It is possible in the tool. So simulation is running and even you can explore a lot of things and we will try to create other structures. So kindly wait for 2 more minutes. Now the one lecture will be taken by my colleague Mr. Sumit. He will take another session for 1 hour, and he will deliver some more insightful talk on different other material calculations. So he's already in the line, and he's going to share his screen and give the more insightful talk. So I am stopping here, but my colleague is joining, and he's sharing his screen. And now next 1 hour, he will give the insightful talk. So please be patient, and we will keep in touch with you. Wait for 2 minutes. Wait for 2 minutes, please. Kindly wait 1 minute.
Yeah, right. Hello. Am I audible, sir?
Yes, you are audible.
Okay. Thank you, sir, for giving me that opportunity to be here. And welcome to all. We will continue with the NanoDcal software, in which I will drive some. Okay. We will continue with the NanoDcal software, in which we will drive some information about our software, which is a NanoDcal, how it is work, and what the parameters we use for these calculations. And after we will perform some simulation, and next day we will try to demonstrate some another complex devices and some another type of materials to use. And so we will start it now. We'll try to start. And first we will go to this slide. So basically, we are talking about the NanoDcal software. In So we'll start it with this slide. We will talking about the NanoDcal software. Basically, NanoDcal software is stand for Nano DFT calculator. Pin code. So we're talking about the NanoDcal software. Basically, NanoDcal stand for Nano DFT calculator. It is a calculator written in MATLAB and C programming language, in which we are in software we work basically for material optimization and simulation of material devices, as well as we are also work with the transistor, including gate characteristics, IGBT characteristics, bipolar transistors. Bipolar transistors characteristics are also possible. Either you are working on any 2D materials or any 2D based device, or that type of nano devices where you can that type of nano devices where you need to derive the electrodes or input what do you need, you can perform on NanoDcal software, in which you can also work with Spintronic devices, and you can define the collinear and non-collinear and associated type application. You can also analysis the DOS, that is a density of state, PDOS, that projected density of state, local density of state, and projected local density of state. You can perform band structures and complex band structure also you can perform. You can also perform the thermal transport tools in this NanoDcal software. In since NanoDcal also works on for material devices, so material part, so you can also get the Phonon tools in this software. So basically, we will talking about all things in this our software. So You all know the sir already you defined that you can build a different type of structure in our user interface. You can also define the molecules like structure, surfaces like structure. You can create the complexest materials and complex structure as well. You can build up the interfaces like structure, and many more things are you can work via our device studio interface. So will directly we are going to on device studio or user interface to perform some calculations. So we'll go first to the device studio. So you know that this is the this is a user interface for the molecule and device structure creation. Since you can create your new project, so we are creating a new project. Click OK, and we'll go to the file directory where you can optional. You can create your project and save there. So I'll have some file directory where I'll save that project. So in my project, I will save the name with I'll save here with the name that is you can I'll pick webinar. So you can save it, and we will perform some formation energy first. So we'll perform some calculation on gallium arsenide and MgO materials. So you know that the formation energy often provides a good explanation about stability of a structure. So we will demonstrate the calculation process by calculating the formation energy of gallium arsenide and some MgO plain material. So we'll save with this name. I'll save this project name with gallium arsenide. So you can save it. Now you can see our device studio user interface and our work environment is ready. Now we are going to take some materials from the our local directly. As you know, we can also get the atoms or molecules or devices from the online directory as well. So we'll first take the gallium arsenide. So we know that we have the gallium arsenide in our local directory. So we'll take this atom from a molecule from local directory. So go to the import option and import local. If someone wants to perform this calculation with us, you can calculate them also. Okay. So in semiconductor, in 3D materials, we go to the semiconductor and we'll take the gallium arsenide. So you can simply search here. You can type with some keyword G like, and you will get the gallium arsenide. See, this is the gallium arsenide molecule with two here the gallium and arsenide. If you know which is gallium and which is arsenide, so click anyone, and right at the left side you can see the properties tab window. In here it gives the coordinate of that gallium atom in which at XYZ axis, and this is the our arsenide. Their coordinate also is given. So we'll now take the some another material from the online directory. So we'll go to the file and import online. So we'll type the GA, that is gallium, and search it. So maybe internet connection. I'll do it again. So we'll 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 do it again. So See, the gallium materials are available here with different isotopes and different configurations, and space groups are there. So we'll keep the gallium GA4, that is a stable molecule. We can, if you want to add this material, we click add. Now this is the gallium 4 GA4 molecule. Now we can change some space group like this via this alternating coordinate group. Like we can perform the calculations on its specific space group. So you can also take the, now first we perform the some calculations of gallium arsenide. After the we will perform the another calculation on another material. So first, see, this is the previously we are talking about the lot of words about the know the things about the rescue software. Now we'll know about the NanoDcal. NanoDcal also previously talked that it's work on MATLAB and C. Basically, this calculator engine is written in MATLAB and C. So you can perform the calculation directly with this user interface is created for the easy calculation for users to perform that easily, and the person who is comfortable in MATLAB, so they can also perform the calculation in MATLAB. After some time, and another session, we'll talking about the complete procedure, how to calculate the calculation in MATLAB via terminals, and another type of Windows OS system like Linux and Mac also possible. So we'll currently perform on this Windows. So go to the NanoDcal option and click SCF calculation. This SCF calculation is generated for the DFT calculation. In every DFT calculation, every DFT calculation, you must have to generate their SCF calculation. In SCF calculation, you provide the sufficient the parameters of for the calculator engine to calculate the specific calculation. So we'll take some values like you can arrange the value, like you can put give the information of what will be the electron temperature in energy cutoff, exchange correlation in LDA and GGA form, like LDA stand for local density approximation and GGA stand for generalized approximation, in which they are currently with they develop with the different pseudo potentials. So we'll take the LDA here, LDA PZ81, and in key point sampling we'll put some values like 15 and also 15. In iteration control, you can put the values for the better calculation and better mixing rate. So in basic set for the web form functions, you can take the values like Hubbard term, and in spin type you can change the spin type, collinear or general spin, and you can change the arrangement as well. So after the putting all type of values, all the value it needs for the SCF calculation, you can click generate files. After the click generating file, you can see here the SCF input file are shown on this user interface. So simply to run this calculation, go to the SCF one and right click and run. When you click the run option, there will be a pop-up window will be generated for the run. Here you can change the gateway location, and if you have a proper license, active license, so you can choose also multiple cores. This core goes to up to 32 cores, so your calculation will be seems to be better for the complex material. So click run. After the running, your job status will be shown here. And if you wanted to cut it, you can cut it simply. And if you want where the calculations are run in the job manager, you can see here your calculation is running. And via I button, you can click the status of your running calculation. So it will take time upon depending upon your system. So you can see here, and we'll in remaining time we will take the another material and calculation. So I will take the another take the simulation with the gallium arsenide, gallium GFAIR. Try with the simulation with this material. So it's still running. So let it be completed. See, the log file is generated. Now log file when generated, the calculation, every calculation you draw with the specific material, the log files are generated. In log files, you can see the actual status of your calculation, what the parameters are calculated here. Like you can see here, the calculation is running. So you can expand it, and you can see here. You can expand it, and you can see here all the parameters you put it in SCF input file. Like when you generate the SCF input file, all parameters are shown here. These parameters is basically generated for the your material. So in which you can see here the basic setting, which you provided in an SCF calculation are shown here, and also the iteration control and the basic set. All things are shown in here. You can also, if you want to change some things like you did not put the correct values, so you can change here also. Like you can change some values, like I will change it to 70 and go to the save option. You can save. This value will be saved for this and this will be saved. Now you can recalculate the calculation. So you can see here your calculation is completed. After the completed this calculation, we will try to get the formation energy of this gallium arsenide. So we have to just do some syntax in this script file. So we'll take type some script for this SCF file for total energy. So for you can see here, if you wanted to see the total energy of this material, so you can go to the MATLAB. So you'll go to the MATLAB. So you have to take another script for the total energy. So write the script for total energy after running the calculation. Okay, like after the calculation is completed, the SCF this SCF input is see here completed. So you can write another script here, like calculation dot name total energy. This is a case sensitive, so you must have to aware of these things. You have to put the correct syntax to run the calculation. So this is the total energy. This is step for the total energy. Simply you can save it and again run this calculation. So after the running it, so the calculation will be running again, and we'll locate this file into the MATLAB so we can see the status of our calculations. So you can simply locate this file. So we'll see, I located this file. So select this folder and we'll show here. You can see that all the calculations are running. You can see here after the see the total energy mat files is generated. You can simply click it, load this total energy.mat file, and after loading it, you can simply type some script that is data. And when you click data, your total energy for this gallium arsenide is seen here. So this way you can find the total energy of any material. Yes, we had some material syntaxes are there on website, so we'll provide it. If you see the syntaxes, so no problem. This is the some. Basically, most of the things are automatic generated in the SCF input. So no worry. This is not necessary to learn the script files. We can all mostly a lot of things are generated in the directly generated into this SCF file. So we'll work now. We'll go with the some another material with which is a MGO. I will try with find a band structure and other type of analysis calculation for the with the NanoDcal software. So I'll take the some molecule from the our local directory. So go to the import option and local file directory. You see here there is a 3D material, and we'll go to the metal oxide and we search for the MGO. The MGO, this is your MGO, this is a magnesium oxide. You can see here, this is a 100 orientation. So in which we make this MGO a slab. So for making slab structure, so we'll go to the build option and click here like surface and slab and put some. We can see this is the slab structure. Simply click on build option. If you have some specific value, you can also provide it here. And if you wanted to create some vacuum in this molecule, you can provide it easily. And here, if you wanted to take the thickness of the slab, if you wanted to increase the thickness and vacuum of this slab, you can simply do it from here. Here you can change your Miller indices. See the 100 plane are created here. So this all the things, it's all about your calculations. Such part. So click on build. Now this our molecules is ready for the calculations. So we'll take some values from we'll calculate some value. But first we calculate the SCF calculation for this molecule. So we'll go to the SCF calculation for this crystal. So you can see here, you can change the values according to your convenience. So these things are generated. Some values are when you do it first time, so some values are given default. That default values are not correct exactly. Some users are uh, s- uh, think that the default values are correct. No, default values are sometimes you have to calculate your values, so your calculation will be correct. So you can choose the value according to your convenience. And we take like the this type of action correlation, and you can put your electron temperature. I like put it at 100, and energy cutoff. You can put the energy cutoff if you wanted to give an iteration. If you are not so wanted to give some energy, you can click on energy, total energy. Uh, you can put the energies and basic set. You can define the Hubbard terms, and you can change the arrangement via element or atom. You can check the spin type or any type of spin like collinear or general spin, and click generate files. See, the CF input are generated. Now we'll try to run this run the calculation for this molecule. So go to the right one, right click and click run option. When you click run, see the running calculation are restarted. So if you wanted to see input, click on right, open with, and you can see here all the parameters you give here automatically generated via like script file. So this script file, you can also change the script file and save it. So now after in meantime, we can take the another analysis, try to calculate another analysis of this device. So you can see here, if you wanted to see the status of your calculation, so you can click right, open with, and you can see your your calculation is started with NanoDcal software, which there is a lot of things it explain here for the cell consistent field calculations. And now we'll try to simulate some another analysis in meantime. Since this NanoDcal software calculate the simulation in Q form. So in before the one is completed, and after another calculation will be done. So go to the analysis part. I will try to get the first band structure, and here you can see here the total energy is shown. You can also check the total energy and charge, and we'll take the, if you wanted to find the density of state, you here just shown here, effective potential, Transchannel, Eigen State, full band structure. These all things you can calculate it. So I will first, you can see here in band structure. In band structure, you must have to know about the Brazilian zone path, in which you can get your exact information about your crystal. So you can check it from your site and apply it. And after total energy, you can know things are have to calculate. So in charge, you can charge, this is the charge atom, you can project it on your manner, like atom, I'll choose it atom. Density of state, you can change the K point sampling and number of energy point. This is a simple density of state, DOS. If you wanted to some PDOS, that is a projected density of state. So you can check, you can take the atom orbital or any type of projection you wanted to, you can click on it. So I'll take the some values like I will take it will be same. We'll take it 3. It will be same here. No matter. Uh, -4, 4. This is a simple DOS. This is a density of state of this device. And after this, if you wanted to interested to calculate the PDOS like and the projected density of state, you can perform it. Now we'll go to the effective potential. As a potential, you can choose the potential via effective or Hartree or exchange correlation or neutral atom. We will choose here effective. In Transchannel, you can paste some values. You could choose here -4,4, and in here you can see here the directions of the direction. You can if you wanted to if you want to know the calculation will be in one direction, two direction, three direction, will be you can choose here. And in Eigen State you can also select the values like k points, k space point, and number of bands. In full band structure you can click choose the values. Now simply after the all the parameters you given by your user side, then click generate file. After that, then clicking on generate file, you can see here all the input points are shown here. Okay, so here I'll before the running the calculation, I will aware you know about the syntax. So you must have the idea about the syntax. So if you know the things like system.object for NanoDcal, this is the NanoDcal file that is calculated for this band structure. Okay, if you wanted to get the raw data or output data, you can simply locate this NanoDcal.object file for band structure in MATLAB. You can get the exact data as well. And you can see the calculation name, that is the band structure. And in K-point sampling, that is the Brillouin part, you can select here, select there in SCF input, and symmetry points are shown here, the number of K-points. So, so for this like visual interaction, see here in MATLAB the percentage shows the comment. When there is a comment, that means that calculation is the syntax is written, there is no meaning. It's not calculated via the calculator. So this is the here. So the calculation dot band instruction dot plot. This syntax is for the MATLAB. If you wanted to plot the data into the MATLAB, if you must have to delete this person. Then when you delete this person button, so we will also generate the MATLAB file in your MATLAB visual MATLAB figure into your MATLAB into your file directory where this performance are calculation there where these calculations are performed. Okay, this calculation.control.xml is equal to true file is generated for the device device studio visual interface. So we'll click on right click and run it. After the running, you can see the running is started. Now we'll do it again for the total energy. So run it, and for charge, same as it is, run it. You can also see the values if you wanted to run it. Things run it, and so see the calculations are having completed. Wait. See, the all calculation are completed one by one, and we'll skip this. We have to also run this and pending calculation. So click on run. See, the calculation is completed one by one, and after the calculation, their XML file, that is the visual interface of graphs, are shown here. So you can see here, if you wanted to see the status of your calculation, you can go to the log file and open it. You can see here all the calculation are one by one is calculated from beginning to end up. So you can see here most of them are calculated. 3 of them are still pending. So first we see the band structure. See the band structure of this MgO molecule. So you see there. So to see the structure of this band structure of this molecule, so go to the right one, press right button and click show view. See, this is your band structure for this MgO molecule. Here you can see here, if this values control, you can get your specific value. Or if you wanted to check your data into some range, you can put the X and Y axis minimum X. And after the things are, you can, if you wanted to see the values in some specific region, so you put it the value and apply the data. This values will be, the band structure will be stored at a specific position. After see, you can see the Fermi level. This is the Fermi level. You can see here, this is the Fermi level. Here, if you wanted to shift it on the top valence band, you can see here, see the top valence band, and this is the conduction band. And this conduction band, if you wanted to shift into the conduction band, you can change shift via this tool. And now if you wanted to change the color of the band structure, you can change to the color. Where like the number of colors are there, you can choose according to your convenience. If you wanted to name another, label another things into the X and Y axis, so you can change via the here, like band structure. You can change via your convenience that what the name will be the structure. And see, and your Brazilian gene zone path is shown here, X, R, G, M, X, G. You can all see here and calculate values easily. So now we have to see another thing. Now we'll see the chart. This is the chart. Now we'll see the let me fix it. Now we'll check the another calculation for density of state. So you can see here some values will be not correct. So density of state are not shown here with the correct value. So no problem. We'll be seen with another calculation. Then we have another 3 or 4 days in which we are I will demonstrate with the perfect devices and material in which you can see the calculations. So you can see here effective potential. So this is the effective potential database. You can see here it is ready. Now if you wanted to see in 2D, So you can see the 2D figure of this effective potential. If you wanted to see the stereoscope display, you can click here and you can see the stereoscope display of this device, molecule. And if you wanted to see the along x-axis, y-axis, and z-axis, you can simply click on it. And if you wanted to see the data into the 1D, so you can see this is the data for this molecule. If you wanted to see in YZ plane, XZ plane, you can click on it. And if you wanted to change the some specific value or specific name, you can change from here. Now we'll see the transmission channel on this survey and see the transmission channel is here, in which the graph is generated for this device. You can see here. This is the graph for this transmission channel with the average over transfer space, the different gauge space value, which is given by the users like us. Okay, so the main thing, if you wanted to get this graph in file directory, so simply export tool is there in every visual file. Every graph file, there is a export tools in there. You can simply click on it and save with your name, like transmission channel. I'll have to save on my. I'll have to do this project. So like I'll save it here. And see here. If I go to that specific file directly, so I'll go to the. So this transmission channel is saved here. You can you can see your data from here. Now we'll see the things like another calculation. So for Eigen State, so view and see this is the Eigen State value of this MgO crystal. So if you wanted to see in with you wanted to color map different color map, you can choose here, and you can also if you wanted to see this data into the 2D path, so you can see the 2D graph of this material. If you wanted to see in stereoscope display, let's see here, this is the stereoscope display of this graph. And if you wanted to see the values at a specific region, you can check it. And if you wanted to see in XY along XY, Z, so you can click on it and you'll see it. And this is the 1D graph, 1D data, that is your graph Eigen State, that is the value versus Z graph, in which you can see your data. You wanted to along YZ plane, along XZ plane, you can choose from here. And if you wanted to see this data into the some specific range, you can put this value. So sometimes things are the calculation are very sometimes you put it the long calculation and the graph is very complex. So that time you can check put some specific range where you wanted to see your data, to see your graph. So you can put here, and if you wanted to export that data, you can export from here. And so in this way, you can use this NanoDcal software to calculate the band structure and every type of material analysis you can do with this NanoDcal software. Like many of them are still pending. We will calculate them step by step and another day. So we calculate like Modulus, Phonon Transchannel. See the phonon density of state, phonon full band structure, then ZT, that is the thermoelectric property, complex band structure, effective but massive, full band structure, Eigen State, Transchannel, potential, electron density, phonon band structure, SCM, charge, band structure, total energy, effective potential, density of state. These all things you can perform easily. Since our software are updated regularly, some it will come with a new features, like another type of parameter will be included. So in this particularly this session was we will do here for material. We completed with material. You can also do the simulation with rescue also and NanoDcal also. But difference in rescue and NanoDcal is some extra calculations are included in rescue software like Raman spectrum, optics property. These all things are you can easily find in rescue. But this type of if you wanted to this type of calculation, you can get it from in NanoDcal software. Or if you now next we will perform the device structure. We will create some devices and get some specific data like wait. So in simulator part, when you select the analysis part, if you make the device, this analysis part comes for the device structure, in which you can get, define the conductance, IV characteristics, and many more properties like also density of state. And there are a number of properties are there, which we perform in next session. So now we'll have to complete this. Now, if you wanted to, I have to calculate the some structure like I have some, now first I have to see this structure in MATLAB. So go to the MATLAB one. See when you perform this calculation, locate that file that where you solve the calculation. See, their MATLAB file also are generated with the calculation part. Their MATLAB part, MATLAB file are also generated in where you can get the data, raw data, and get the output values are here. See, like you put type discrete data, you can see all the transmission function. Like you can see here, I have to see the what energy points it's taken. So you can simply click on data dot energy points. Click enter. See the energy points are there. The energy points to use this in calculation. You can simply this way you can get the data of your calculation. If you want to see the Eigen State value, so click load it and simply click on write the data and see the values are given. If you want to see the Fermi energy, so click data dot Fermi energy. Click into this is your Fermi energy value. You can see here. So similar way you can define. You can get the every value data in MATLAB. So effective potential. Like for the effective potential, we can see here data. Like see this is also the things are created. Like we have to know about the things. What is the functional labels, system messages, regional point position, and region vectors. These things are used for this calculation. So now we will go again for our device studio. See,
sir.
Yeah, tell me.
Can you get band gap from here also?
At MATLAB, you wanted to, calculate the MATLAB, see the graph on MATLAB, no?
From that graph, you have to calculate or you have to.
See here in band structure, there is a syntax are generated. Some default structure, some default. I'll say that earlier that default syntax generated, in which that is the calculation dot band structure dot plot value. If you this is the percentage, that means it is a commented. That means this syntax will not participate into the calculation. So simply you can remove this percentage and save it. When you save it and recalculate again, like I will recalculate again, run it again. When you run it again, you can see here. I'll show you the after the calculation what will we get. See, calculation is running. See, maybe the calculation is okay. When the calculation will be completed, the graph will be shown. Graph will be seen in your MATLAB file. MATLAB graph will be shown. You can able to see the graph into the MATLAB. Like let it be completed. This will if you wanted to see the what properties could this NanoDcal solve for the device, so you can see like I will import the some project from local directory. So I'll have to do it from here. See, the calculation is completed. Let it be configured. In meantime, we'll just see the properties of that example. In example, there is a ORM alkanoethyl AU device. If you wanted to see what type of property can calculate this NanoDcal, so simply go on simulator NanoDcal and in analysis part, see the this is the analysis part of the device, that is calculate this NanoDcal software, like density of state, effective potential, total energy, scattering state. This all properties I will demonstrate in next session. So don't worry, like transmission, photocurrent, IV curve, charge, electron density, potential, conductance, thermoelectric current, seebeck coefficient. This all calculation will be I will perform on next session. So let it see the completed or not. See, this is taking some configured time. So after the configuring, your there in MATLAB directory, there they see this is your figure. MATLAB figure are generated for this band structure. Can you see it?
Yes, yes.
Okay. See, the band structure dot figure file is generated for that particular band structure. Okay. You can simply click on it and see the your data in your MATLAB also. Okay. This is your formula and this is your band structure value. If you wanted, but in MATLAB you cannot able to see the specific things in the specific things in this band structure. So in device today, we will provide a lot of tools. You can work with this when you, as it is work with this device studio, give your time, that will be familiar you, and it will help you to lot in your structure. So you can see the points of the particular point of this structure. So for today, this will be sufficient for us, you. And after the another session, we will demonstrate another type of complex devices, complex material structure, and try to configure and try to configure the another property. Okay. Anyone? Okay. Anyone having a question regarding this simulation? We done it earlier. Okay, so now we can
So that band gap value that directly cannot be seen through MATLAB, right?
what did you say?
That band gap value, just like you have calculated
See,
total
I
energy.
earlier said that device, that NanoDcal engine, is right in MATLAB. It's premier, it is written in MATLAB. So if you will you will first need to MATLAB, so you can see the all data. Okay,
Okay.
but
Okay.
also if you want, if you wanted to see the data at a specific region, so you can go here like show view option, and if you have some specific region, you can put here, and the graph will be shown there, and you can take the some you can calculate their value. Like, but for output, you must have to know about the must have to calculation for the you can go on MATLAB, you will be take your data output as well.
Okay, thank you.
Okay. Anyone have any questions? So please ask me. If I able to give you, that will be helping for me and you also. So anyone? Okay. So okay, we now close this presentation here. We will meet tomorrow with another simulation. So thank you all.
Okay, thank you, sir.